you're curious on learning how AI agents work under the hood, continue watching this video. I will be revealing the mechanics of AI agents through a simple design pattern. By the end of this video, you will know what AI agents are, you'll know how they work under the hood, and you'll be able to build your own from scratch without using any intermediary libraries like LangChain or LlamaIndex. The GitHub repository for this project is available in the description to this video, so feel free to check that out and follow along if you wish. The project works on Ollama and also OpenAI. It's prudent to start off with defining exactly what I mean when I say AI agent. So in this case, what I'm talking about is an agent that is essentially powered by a large language model, and it has the ability to affect its environment by the use of tools in which that you can define however way you want. Those tools are usually functions in whatever programming language you're operating in. In this case, it's Python. So the agent powered by the large language model can take in a query and reason about that query and decide whether or not it needs to use particular tools, and then actually use those tools to affect an outcome or to affect its environment. In this case, we're talking digital environments. If you pay attention to the graphic on the screen now, you'll see an example of this. So we have an AI agent that's asked a question, a mathematics question. It's really simple in this case. What's 5 plus 10? The agent has access to a toolbox, and based on the question, the agent can reason about that toolbox and decide whether it needs to use the basic calculator or the string reversal tool. In this case, it knows it needs to use the calculator. It uses the calculator and delivers an answer to the query. It's really as simple as that. So let's see how this stuff works under the hood. So imagine we receive a query. The query is something simple, some simple arithmetic. What's 5 plus 10? You move into this section here, and the trick behind agents is there is some prompt engineering behind the scenes where you give the large language model a description of all of the tools available to it. Because these tools are defined in Python, we can actually give the tools doc strings, and those doc strings can act as descriptions for the agent itself. So within the toolbox, we have a description of the calculator tool, and that description will tell the large language model what inputs the tool requires and what outputs the tool delivers. So it's like a standard doc string that you would write for a Python function. If it's not clear now, you will see it clearly in the code. The same for the string reverser. So the large language model can look at the descriptions here and decide based on the query that it receives which tool is appropriate, or if it needs to use any tool at all. Because some queries that come in, you might not want the model to actually use a tool. You might want the model just to respond as is. So there's where the reasoning component comes in. So that's the first key step in making an agent work. The next step is this JSON outcome. So because these tools are Python functions, we actually need the arguments to be put into the tool in a structured way. So once the LLM decides what tool to use, it will also generate the input for that tool. And it knows the input because it has a description of the tool. That description tells the large language model what the input should look like for that tool. So we can get the large language model to generate a JSON, which will have the tool as one of the keys, and the value will be the tool that it needs to use. So in this case, it's the calculator, and then the input to the tool as the other key. And the values there will be the correct inputs for the tool based on the query. So in this case, we're doing 5 and 10, and the operation we're doing is add, because the tool, the calculator tool, expects you to put one number. So it adds 2 numbers, or it can do any mathematical operation on 2 numbers, or any arithmetic operation on 2 numbers. So in this case, we have 5 and 10, and the operation we're looking for is add. The next key part to the agent is actually being able to execute that function. So when you look at the Python code for this, you're going to see within the agent, there is a method that you can use to execute that function once you've got the inputs. On executing that function, you will generate a response, and the response in this case is 15. The key things to understand about agents is that they're able to reason about their tools. And the reason they're able to reason about their tools is because in some way, in the prompt, you have provided them with descriptions of the tools. I do this through a toolbox class that I'll show you. They're able to generate the appropriate tool to use and also the inputs for that tool. And that's usually done through a JSON. Some approaches use function calling to do this, but JSON generation from large language models is getting better. So using JSON is also an appropriate way to do it. And then those inputs are put into the tool, which is usually some kind of function in the programming language you're operating in. In this case, I'm using Python. So it's a Python function, and that function is executed and the response is delivered. That is agents in a nutshell. Let's concretize this by diving into the code and then walking through some examples of this particular agent in use. Let's talk through the Python code. The Python code has what I'd like to believe is a relatively simple structure. You have your agent. Ultimately, that's where you bring everything together to create this agent that we've been describing. Configurations is where you set your API keys. If you're using the OpenAI service. Models, this is where I have defined classes for the different model services. So there's a class for OpenAI, and there is also a class for Ollama. And if you want to add any other model service, you can just follow the pattern that I've established for adding classes here. Prompts, this is where we define the prompt for the agent. I've put in place a basic prompt, but if you're using this project and you want to iterate on that, you may wish to do so. Tools, where we define every tool that we want to be available to the agent within this project. So I've defined two basic tools for the purpose of this demonstration, the basic calculator and the string reverser. But if you're using this as a template, you can go into the tools module and add whatever tool you wish. And those tools can be as sophisticated as you want. And then there are some utilities here, which are just helper functions, really to do things like read in API keys. You probably won't have to mess around too much with that unless you're adding a different API service, in which case you will. Let's start off by looking at the prompts.py. So this is the basic prompt I have for the agent. I'll read through this really quickly. I'll skim it to give you an idea of what's going on. So it says you are an agent with access to a toolbox. Given a user query, you will determine which tool, if any, is best suited to answer the query. You will generate the following JSON response. And this is key. Tool choice, and then the name of the tool, obviously, and then tool input, and then the inputs to the tool, obviously, as well. So we've defined a little bit more detail about what tool choice is, the name of the tool you want to use. It must be a tool from your toolbox or no tool if you do not need to use a tool. So that's key there, because otherwise, if you don't specify that, the model may try to use tools to answer questions that don't need the tool to be answered. And then we have tool input, and that's the specific inputs required for the selected tool. If no tool, just provide a response to the query. So in this case, if we're not using a tool, the agent just provides the response to the query in tool input. So that's a slight shortcut, but it's clarified there in the prompt. And then we've got a description of tools here. And that's what's provided here. And I'll show you how that comes in as we step through the code. That's the prompt, fairly basic. Let's move on to seeing actually how the tools are defined. So I'll give the basic calculator as an example here. So we have the basic calculator, and it is very rudimentary. All it can really do is take two numbers and perform an arithmetic operation on those numbers. That's all we're doing here. This is not anything sophisticated. So if you're using this for an example yourself, just bear that in mind. This basic calculator is, as it says on the tin, it's basic. So I'm not going to go through all of the functionality. You can look through that yourself. It should be pretty obvious from here, the type of things that it can do. What is important, though, is this doc string. This doc string provides the large language model with an example of exactly how this tool should be used. And it's important that if you are using tools, or if you're creating your own tools, you create a doc string that is as comprehensive as the one you see here. So we have the input parameters, and it tells exactly what the input parameters are. So in this case, the input string is a JSON string, and it defines the first number and the second number that we want to perform operations on. And it also defines the operation that we want to perform. And the large language model must return the JSON string exactly as you see here. And that's why we provide it in the doc string, and that doc string can be read into the prompt. I'll show you how that's done in a moment, in a few steps in this code. And then we give the large language model an idea of the response. So it returns formatted result of the operation. And there we go. That is the doc string. And this is really key in terms of getting the agent to use tools. Let's talk about how we get the agent to actually return a JSON. So I'll step into the OpenAI class that I've defined. I like to use the request library because when I'm integrating other services, I can just follow the same pattern. All I have to change is the endpoint usually, and sometimes the payload. And then sometimes the way I format the response is a bit different, but I can use this exact same pattern for most of the large language model services I want to use. And I don't have to install any additional libraries. That's why I like to use this pattern. To get the model to return in JSON, most services will provide you with an option to format the model in JSON. So in Ollama, there's a format option, and you just specify that as JSON. For OpenAI, you have to specify this response format as a JSON object. But this is key because we want this large language model as part of our agent system to return its response in a JSON format. This is absolutely key. You need to ensure that whatever service or model you use can generate JSON formats reliably. So that's the OpenAI model, and this is the model class I've set up to be used within the agent. Let's take a look at the toolbox next, and let's see how the toolbox works. So in this case, the toolbox is really key as a class to this overall agent structure. The toolbox is initialized, and it has two methods. It has a store method, and it has a tools method. And I'll talk through what each of those do. The store method takes in a list of functions, and those functions are obviously the tools you define. So I showed you one earlier. I showed you the basic calculator, but there's another function here, the reverser. So what we do here is we take in a list of functions and we return a dictionary with the function names as keys and the values of those keys are the doc strings for those functions. So we get the exact function name here. So you can see that. That's how we get the exact function name from the list of functions that we return. So for every function in our list of function, we get the exact function name, and that's the key to our dictionary. And look, we've defined this dictionary empty at the top. So when we initialize this toolbox tool, we have an empty dictionary for our tools. So that's the key. And then the value is the doc string. So we can get the exact name of the function and the doc string behind it. So we return that dictionary. And then the tools is simple. We return the dictionary string for that dictionary that we defined when we stored those tools. So we're doing two operations. We're storing the tools, which is essentially just getting the name of the tool and the description. And then we're returning that as a dictionary string. And the reason we want to return that as a string is because we want to feed that into our prompt. And if you recall, there's space in our prompt here to give our description of the tool. So that's going to come in as a dictionary there. So these are a result of the operations we perform with that toolbox class. That's how we get the description of the tool to be understood by the large language model we're using. Let's see how we pull everything together by defining our agent. I'll scroll up to the top here. So I've defined an agent class, and this is kind of the central point of pulling every component together that we need to build our agent. So the agent class is initialized with tools, a model service. So the model service is just the model class I showed you earlier. I showed you the OpenAI class. Obviously a model name as well, because we want to be able to use different models with the agent. We want to be able to specify that. Stop tokens, that's for when you're using the open source model. So a lot of open source models require you to define a stop token. So that is what we're doing here. The agent has several methods. The first method is to prepare the tools. So this should make sense to you, because what we're doing here is we're making use of that toolbox class that I've just showed you. We're storing our tools, and then we're getting our tool descriptions. So we're returning our tool descriptions. That's how we prepare the tools. We store the tools using the toolbox class, and then we return the tool descriptions. Then it has a think method. This is where we're making use of the large language model. So notice we have our tool descriptions. So we're using our prepare tools method that we defined earlier in the agent class. We're setting up our agent system prompt. So this is from the agent system prompt template that I showed you in the prompts.py. And remember, that template takes the tool descriptions. And we return the tool descriptions by running the prepare tools method in this agent class. Then we're simply feeding this to the large language model. So if you're using the Ollama class, if you're using an Ollama service, you'll need to return a stop token. That's why this if statement is here. Otherwise, you don't need the stop token if you're using the OpenAI class. So that's why this is why this is set up conditionally. But essentially, all we're doing here is we're feeding the model name, the system prompt, which is the agent system prompt, and the temperature. That's what we're feeding. That's how we're instantiating our model to be used within our agent. Then we can ask the model to generate a response, and we take a prompt. So that user prompt that comes in might be a question on mathematics. What's 5 plus 10? It could be, please reverse this string. It could be anything. It could be something that doesn't require any of those tools. But essentially, that's what we're doing. Once we've established our model instance, we are generating the prompt, and then we're returning the response from the agent. The next method here is the work method. And in the work method, that's where we actually execute the functions that we may or may not have selected, right? Because sometimes we're not using any of the tools. So this is where we execute our tools in the work method. So the first thing is to actually return the response from the large language model. And that's where we do the think aspect. And remember, this is going to be a dictionary where the first key in the dictionary will be the tool choice, and the second key will be the input to the tool. So then what we're doing is we're grabbing that tool choice from that dictionary, get tool choice, and we're grabbing the input to the tool from that dictionary. So then we're looking at our tools, and if the tool choice is within the tool set, so basically if we are choosing to use a tool, we will execute that function, and that's how we're executing the function. We're using the tool and the tool input. That's how we execute the function. And then we're returning that to the screen. If we have selected not to use a tool, we will just simply return the tool input. And remember, in the case where we're not using a tool, the large language model will just generate a response as is, and we will return that to the screen. And that is it. That's the agent class. That's everything put together. What I'm going to show you next should help to concretize it further, because we're going to show you an example. I'll show you how you set up the agent to use with the agent class. And, it should be simple, because We're using the class, so I'm going to abstract a lot of this stuff away from you. You'll see it next, and I'll show you how well this agent actually can reason about using tools. And we'll do several scenarios. We'll do a scenario where I ask it to add some numbers. We'll do a scenario where I ask it to reverse a string. And then we'll do a trick scenario at the end just to see how well this agent can actually reason. I want to demonstrate to you how this agent works. And I'm going to do this by running through 3 examples. I'm going to use the OpenAI model service. I'm going to use GPT 4.0 initially, and then we'll try it with GPT 3.5 Turbo just to see the capabilities. I'll do a math scenario. I'm going to do a reverse string scenario. Then I'm going to do a couple of trick scenarios just to push the agent to the limit and see what it can really do. When you're setting up your agent, you define your tools. You define your model service and the model. The stop token is only to be used if you're using the open source models from Ollama or any other open source model. And then you put it all together in this agent class. And that's it. We go into the PowerShell and we can run this agent.py script, and that will set up an input for us where we can input the query into the agent. A quick note on Ollama. I'm having some issues running some of the larger models on Ollama with my laptop. So I won't be demonstrating the Ollama model. However, if you do have a better spec laptop than me and you can get Ollama running on your GPUs, you're more than welcome to run this with Ollama. So I have built the integration. I haven't been able to test it rigorously, so forgive me if there are some bugs in there. But those bugs should just be formatting things rather than actual bugs with the agent itself. I suspect that if you're running with Ollama, you won't be able to do this with anything smaller than maybe a 22 billion parameter model, let's say. I suspect you'll run into difficulties, but you can give it a try and see what happens. Saying all of that, let's get into the demonstration. So I'm going to bring up my PowerShell. Before I do that, something that I need to mention really quickly. I have a marker here in each tool that tells you that the tool was used to generate the answer. So you'll see if the tool was used to generate the answer, you'll see calculated with basic calculator for the calculator tool. And the reason is large language models can actually add numbers. They don't do it very well. They can divide numbers as well. They can do mathematical operations. And yeah, for simple ones, they can do them easily, but for more complex operations, they don't do them very well. The reason I have this tag is to show you that the calculator tool was actually used and it wasn't just the model generating the response by itself. So that's why I have the tag there. It will become clear once I'm doing the demo. All right, let's pull up the PowerShell. I'm going to start my agent by running Python agents.agent. That will get my agent up and running. As you can see, it says, ask me anything. If you do want to exit this, you can just type exit in lowercase. Let's start off with an arithmetic question. So let's say, let's just make it hard. So we've asked an arithmetic question. I'm going to zoom in a little bit so you can see it. So we get a response here. So we get a response from the OpenAI model. Tool choice, basic calculator. So it's worked out that we need to use the basic calculator. It's given us our tool input. And then we've got an answer here. And you can see that it's tagged. We've calculated with basic calculator. So the agent has correctly identified from there that we need to use the basic calculator. It's given us an input, and then we've calculated the response. Let's try something else. How about, please reverse this string for me? Let's see what happens. Spelled reverse wrong, but let's see if the agent can figure it out. It has. So it says tool choice, reverse string, tool input, this string for me. And notice that it's not reversed the entire thing. It's just reversed this string for me. And you can see the reverse of the string. And you can see it's tagged with the executed using the reverse string function. Now, if we wanted it to reverse the entire string, we could write something like, please reverse the entire string for me. Let's see what it does. So this time, we have the entire string reversed. And we have used the reverse function. So you can see here, the agent's able to reason and determine whether or not we want to use the basic calculator or to use the reverse string. What if we ask it a question that doesn't require any of the tools? Let's do this. What's the capital of the USA? There we go. So you can see here, tool choice is no tool. And then we just simply return the tool input, which is a response generated by the large language model. So we have the capital of the USA is Washington, D.C. Let's move on to a trick scenario. So some of you might have heard of the game Simon Says. Basically, to explain it in short, Simon Says is a game that children play where you are asked to do something. And if Simon doesn't say to do it, and you do it, you've lost the game. If Simon says to do it, and you don't do it, you've lost the game. So you must only execute the task you asked to do if Simon says to do it. I think it's best if I show you by typing out. So I'm going to say to the agent, you are playing the game Simon Says. You must only execute the instruction if Simon says to do it. We have started the game. Now, reverse this entire string, please. So I'll read that again. You are playing the game, Simon Says. You must only execute the instruction if Simon says to do it. We have started the game now. Reverse this entire string, please. Let's see if the agent can reason about this. So if it does this correctly, it shouldn't reverse the string. There we go. So the agent was able to reason that we're playing Simon Says, and it says tool choice, no tool, tool input. Simon did not say reverse the string. Let's try the same thing, but with a math scenario. You are playing the game Simon Says. You must only execute the instruction if Simon says to do it. I've started the game. Let's see. Let's see. So we're now doing a numeric operation. Let's see if the agent says. There we go. So since Simon didn't say to perform the calculation, I won't execute the instruction. So that works pretty well. How about we see how this works with GPT 3.5 Turbo? So I've hit exit. In my code, I'm going to change the model name. So instead of using GPT 4.0, which seems to work quite well as this basic agent that I've set up, let's use GPT 3.5 Turbo. Now I'm going to initialize the agent by running Python module agents.agent. Ask me anything. So let's first ask a mathematical question. Let's do something simple. Is we want to make sure that the agent actually executes it rather than just returning the large language model response. So yeah, there we go. We have the tool input. The answer is 11. And you can see, even with GPT 3.5 Turbo, the agent was able to reason that we needed to use the calculator. let's do a string reversal. This entire string. There we go. So we have, please reverse this entire string. And we have that reversed. So the agent was able to execute that. Let's try something that doesn't require any tools. What's the population of Nigeria? Let's try that. Let's try something a little bit different. There we go. So the agent knows that we don't need to use any tools, and it's returned a response. The population of Nigeria is approximately 206 million. Now, this is even with GPT 3.5 Turbo. Let's try the Simon Says example. You are playing the game Simon Says. You must only execute an instruction if Simon says to do it. We game. Please reverse this entire string. Let's see what happens. So two things have happened here. First of all, the way that GPT 3.5 Turbo actually determines the JSON dictionary here is inconsistent. So you can see here, in this instance, it says tool input, and then we've got a dictionary, and then we've got input string, and then we actually have a value here. But if you notice, the last time we asked it to do a reversal with GPT 3.5 Turbo, it just simply had tool choice, reverse string, tool input, and then we had the tool input in this form. So it wasn't as a dictionary, it was just as a string that we picked up. So GPT 3.5 has that level of inconsistency, and I think you could probably solve that by just being a bit more specific in the prompting. The other thing to notice here is that it actually chose the wrong option. So Simon didn't say to reverse the string, and in this case, GPT 3.5 Turbo actually chose to use the reverse string tool, which is incorrect in this case. So that is a fail from GPT 3.5 Turbo in the reasoning, and it just goes to show you that these agents can be fairly powerful, but they still do require the most state-of-the-art models in terms of their reasoning capabilities. So I wouldn't advise using agents with GPT 3.5 Turbo. If you're going to use agents, use the state-of-the-art models available to you. And also, if you're going to use this pattern, it's probably worthwhile just specifying a little bit more exactly how you want the inputs to be returned. And that might be able to get it to run more consistently with models that don't generate JSON as consistently as they should. That's it. That's agents in a nutshell. Hopefully you enjoyed the demo. If you like this content, give us a thumbs up. Give us your opinions in the comments section about agents. Like, share, and subscribe to the channel for more large language model content. This agent obviously can serve in larger agent frameworks where you're using multiple agents. But feel free to take this pattern and adapt it for whatever use case you have. Thanks for tuning in, and I'll see you again in the next video.